Welcome to the lecture 2.2. We will learn about objects in Python and what is dynamic typing, the property of Python language, and summary of data types. The focus is not going to go into the details of data type in this lecture itself. We will be studying them in detail in the subsequent lectures about data types. I will talk about dynamic typing once we understand what are objects in Python. Suppose you have a variable x and you want to assign a value 10. Then another variable y, even that you want to assign a variable value 10. In Python, you don't need to mention any type of the variable that you are declaring. Whereas in a C language, if you need to do the same thing, you know that the value of 10 is an integer and the variable name is x and the variable name is y here. If you want to do the same thing in C, you have to mention first integer, then the variable name x and equate it to a value 10. Then if you need another variable, an integer variable y, you have to declare it like this in a language like C. Now, what are we doing here in C? First, let us understand what is being done in C. Then I will talk about what is unique in Python. Here, the variable x is a label or a name of a variable. Now, when I declare x, we need to also mention what is the type of the variable. So here I am saying x is an integer. This is the information given to the C compiler to make sure that what you assign matches with what type you have mentioned. Suppose I say that I am declaring a variable int a, and then I say I am assigning a value 4.0, which is not an integer, which is a floating point number. Then the compiler, when it looks into this code, it will give an error saying that you are trying to assign a floating point value into an integer type a variable of name a, which is of integer type. You are assigning a floating point value. So it will catch that during the compilation time and then flag an error that you are doing something wrong. Then if you want to avoid this error, you may have to do a equal to, suppose I am writing the code again, a is equal to, I will typecast it saying that even though I am giving a floating point value, you typecast it to an integer, then the 4.0 will become a value 4, and then 4 is assigned into variable a. So now when this code is seen by the compiler, it doesn't give an error, it accepts this conversion. And one more thing, what happens in C languages, it reserves some space in the memory. This is the memory. And then this memory has some address. So let me call it as address x. And this x variable is located in this address, and a value of, maybe this is 10, let me say this, value of 10 is stored in the memory, and then this value is actually assigned a value 10, means the address at which the variable x is located is stored a value 10. So when I assign this 10 gets written here. After some time in the code, if I assign a value of 20, then this value will be overwritten with 20. So any variable is associated with the location in the memory, and you can assign the value to a variable. That time that location in the memory is return the value of whatever you are assigning. Now, suppose if I declare a variable int star address of address x, then I can assign the address of x in C. Assuming that x is already declared, I am declaring a variable int star. That means it's a pointer to an integer. Yeah, it's a pointer address x, address of x. I am assigning ampersand x. This is the indirection that I am extracting the address of the variable x. That means where whatever is the value, suppose this is some 0x hexadecimal value 2000. Now this variable is assigned the address 0x hexadecimal value 2000. Now where is this address variable is? That will be another location. Its address will be something else. It could be some address y, some other address. And the address x variable, whatever I declared here, is located in this. And then I am assigning this 2000 value into this place. So 0x. This is what happens in C, and you are allowed to access the address of the variable in C. Now, what is the uniqueness as far as the Python is concerned? Now, when I say x is equal to 10, the variable is x again, but the value 10 is not an integer value which is going into the variable x. Whatever the constants, that is, this is a constant that you are declaring in a Python code, it is created as, suppose this is an integer now, it is created as an integer object. I will talk about objects later. Now you can understand that this is not as just a value 10. It has other information also about this integer object. Okay. Now, this value 10 is stored as a part of this integer object. This object itself is not only going to occupy 4 bytes or 8 bytes based on the size of the integer. It could be much more because the object is going to have additional information about this. Now, once this value is there in the program, an object is created with the value initialized, and then wherever this object is, suppose it is in some location, I will call it as ID 1, some value, it is in the object memory, that is assigned to the index, that is assigned to the variable x. Now this label x is bound to the address of the object. Now, can I access this, whatever may be the address, can I know? Yes, you have an option, the ID of x you can do, and then you can get the address of this variable. But can I use it to access it? No, you can use it only as a variable x. You cannot get the access the memory or access the object in Python. You can access it using only the labels which are declared by you, or in the sense it's defined by you with the initialized value. So whenever you want to access this object, you need to use the value x to access it. Now, I said that we have a variable x and then a variable y. We write it like this. There is no semicolon later on. It's just two instructions. When this is done, this variable x and this variable x and y, they point to the same integer object 10. That is what is shown here. Suppose I have an integer object, a value 7, and a variable names are a and b. This, whatever you are shown here, actually is because of this following assignments that has happened. Now, what is done first? First, an integer object of this value is created, and then its ID is stored in the variables, or this variable is bound to this object. I could say this way, this variable is bound to the object, or I can also say that the ID or the address of this object is assigned or stored in the variables A and B in Python. Everything is an object in Python. I will explain you more and more as we get into the more details. When an integer value is assigned, memory for that value is reserved, and the address is assigned to the variable. Different variables to the same value. Suppose if you have multiple variables are assigned the same value 10, then Python does not create multiple integer objects with the same value. It creates only one, and then all the variables which are pointing to the same object, they are all given the same address of this object. Beauty of Python is that there is no limit on the size of the integer. Now, this is something unique about Python. You know, in C programming, if it is a 32-bit machine, if the CPU is a 32-bit machine, if I declare a variable int I, and then if I look at the size of I will get number of bytes that this variable I occupies in the memory. Suppose if I store this value I in the memory, it is going to occupy 4 bytes in a 32-bit machine. Then the size of operator in C language on the variable I returns a value 4. Now, if it is a 64-bit machine, then you may get 8. So it depends on the CPU on which this C program is written. And it is limited by number of bytes that integer can occupy. I can have a long, in case if I want a wider, or long based on the machine or a CPU that the C program is running on. Whereas in Python, there is no limit on how many bits that you can have for an integer value. That I will explain it to you later in a section, that the integer, there is nothing called integer declaration in Python. So I can say I can assign 999 to any length of value and still it will accept it. The size of bytes reserved for the integer object increases with the size of the value stored in it. So as you assign a higher value into an integer object, it grows. So there is no upper limit of how much you can store in an integer object in Python. We will look into this system library commands later on. Size sys dot get size of a variable. There are many methods defined for each of the built-in data types. These are all, I call them as built-in data types. Integer is one of them. We will see few of them, other data objects, data types soon. Now, what is a dynamic typing in Python? Python is dynamically typed language, means that the Python interpreter does type checking only as the code runs, and the type of a variable is allowed to change over its lifetime. So let me explain. Suppose I said that I am assigning a value 10 here. Now, what is the type of X? Because I am assigning an integer object, this is a type int. Now, after I make use of this value X with the variable X with the value 10, I can decide to change it in the same namespace, in the same code, in the same function. I can say assign X is equal to 2.53. Now I am assigning a floating point number. It does not give you any error. Now, from this time onwards, the Python assumes that the name variable X is now pointing at a floating point object. Whereas in C, if I declare int x is equal to 10, after few lines of code in the same code, if I change x is equal to 4.50, it is not going to accept it because it associates this value variable x of with a type integer. So if I assign a floating point number, compiler will give an error. Whereas in Python, you are allowed to do it. This is what is called a dynamically typed language. So Python is one of them. Other languages like C, C++, and Java, there is a strict declaration of types of variables before assigning values to them. Python does not know about the type of a variable until the code is run and the variable is assigned a value. So just since we are not giving any declaration like integer, the type of the variable is decided by the value that you assign to it. So if I assign a value integer, it becomes an integer object. If I assign x is equal to 6.5, it becomes a floating point object. So it depends on the value that is getting assigned into a variable. The variable name is bound to the object it is pointing to. When a value is assigned to a variable, a reference or address, which I mentioned, of this object is stored into the variable, not the value held by the object. So is always what is stored in the variable is not the actual value. If I say x is equal to 10, x is not holding the value 10. 10 is somewhere in the memory, an integer object is created, and the address of that or some ID, I can call it as ID, of that object is stored in X. Always they store the addresses or the ID of the objects where they lie in the memory. It doesn't hold the values of those objects. The value is stored inside the object. MyInt now assigns the address of this integer object in memory. Whatever is the address where this 2 is stored, that address is given assigned to the variable myInt. MyString, the address where the string is stored, string object is stored, is put into the variable. Similarly, a floating point object. All the variables in a Python program hold the addresses or references to the objects they point to. This is a very important point you should remember. ID of something, a variable, is a system library function which gives you the address of the object. It's only true in case of C Python. So you can assume that some address or a ID, unique ID of variable gets into the variable that you are assigning, and this function ID returns you that value, okay, whatever may be the address. So let me explain what I mean by the ID of something. Now suppose I declare x is equal to 10. Now I said that this object, integer object, is created in the memory, and the address or ID, I may call it as any one of them. So let us, going forward, let us call it as an ID. ID of this object, which is unique, is assigned to x. Now, I don't know what is this value. If I want to know the value, there is a function called ID of x, which returns you the value of this address where this object is created. So let us, whatever you learned now, quickly we will see it in a program. Now, I said x is equal to 10. Now print x, and then let us print it now. X equal to 10. Now, let us look at the value of ID where this integer object is. Now I can call the function ID, which is a built-in function of Python. I need to give the variable now. When I do this, I am extracting the address where this integer object 10 is stored. created and kept. So if I do that, I get a number, which could be an address or is a unique ID where this variable exists. Now, I also mentioned that if I have another variable y, and then if I assign the same value 10, that variable is going to hold the address of the same integer object. So let us check it out here. I am trying to get the address of this object 10, whether the variable y is also assigned the address of this integer object, which is holding the value 10 or not. So if I do that, let me clear the screen. Clear is a command. If I run this, I get the same address in both the places. That means this variable x is holding the address of the integer object 10 wherever it is in the memory. Similarly, since these values are the same object is there in the memory, and variable y is also given the same address. That's why when I print the value of the address of this integer object, which is nothing but id of y, it gives you the address that is stored in y. So I get the same thing here. We can also do I can access it as an integer object also. I am trying to get the address where this integer 10 is stored in the memory. I get the same thing here. I hope this is clear to you. Let us continue further in the next section. See you then. Bye-bye.